Hi everyone, welcome to Java Techie. So in this tutorial, we'll discuss about another super interesting topic, that is database locking mechanism. Okay, so imagine this, where multiple users trying to update the same data at the same time. Now keeping your data consistent during this situation is tricky part, isn't it? So how to avoid this? So that's where Spring Boot and Hibernate come to rescue us with two powerful strategies, that is optimistic and pessimistic locking. Using these strategies, you can manage concurrency and ensure your data always stays safe and consistent. And guess what? It all starts with the magic of transactional annotation. So in this video, we'll break down how these locking mechanism work with real world examples. Okay, alright. So without any further delay, let's get started. So before we directly jump into the code, first let's understand what is this locking mechanism and how they work at a high level. Then we'll do the postmortem by writing our actual code. So to demonstrate this locking mechanism, we'll take one valid real-time use case, that is movie seat booking, or you can consider railway ticket reservation, any kind of use case you can consider. Now think about when multiple user will try to book a single ticket. Okay, then how the things will be work behind the scene. Let's understand that. Then we'll implement the same in action. So if you observe here, I have created a table called seat, and then we have the field called ID, name, and whether it is booked or not. We have these three fields. Fine. Now what we want to do here? We want to understand how concurrent seat booking to this particular database will be handled by two different strategies, that is optimistic locking and pessimistic locking. So first, let's discuss how optimistic locking mechanism handle the concurrent request to a database. Okay, so what we can do, let me keep a note of it. In optimistic locking mechanism, how it works, it maintain a column called version. Okay, so let me add another column here, that is version. Initially the version will be 0. Now let's imagine there are two threads, thread 1 and thread 2. These two thread wants to book the movie ticket of Titanic. Okay, and there is only one ticket available. Let's say this TH1 and TH2, which is nothing my two thread, wants to book the same ticket. Now, how this optimistic locking mechanism work, or how it handle the concurrent request? So to book a ticket, both the thread first needs to fetch the record from the DB. So let's say this thread 1 fetch the record ID equal to 1, movie name is Titanic, status is false, and version number is 0. Now thread 2 also fetch the same information, false, and version number 0. Now what happened? Let's say this thread 1 first get a chance to update the ticket. Then what will happen? Once thread 1 will update the or book the ticket, the status will be changed to true and this version number will change to 1. Okay. Now thread 1 book the ticket. Now at the same time, when thread 2 will try to book the same ticket, what it will observe? Currently thread 2 have the copy of ID 1, movie name Titanic, status is false, and version number is 0. Now since thread 1 update the ticket or book the ticket, the version number was changed to 1. So when thread 2 will try to update or book the ticket, the version number is 0 here and the version number is 1 here. This guy is having 0 and this guy is having 1 as a version number. So this is version mismatch. If there is a version mismatch found, then immediately this optimistic locking will throw the optimistic locking exception, saying that another thread already update or delete the record, or ongoing transaction was there, so you will not be able to book the ticket. So all the things will be handled by this column called version. So once version number is update, then the other thread will try to do some operation. The version number must need to match. If there is a mismatch between the version number, then it will simply throw you the exception. This is what how optimistic locking works internally. Okay, now let's discuss about pessimistic locking. That is the straightforward approach. Now how this pessimistic locking works, it's very simple. Now you have the same database, right? Now this pessimistic locking, let me keep a database again. Here we don't need any version. Okay, let's say id, name of the movie, and status. Okay, whether it is booked or not, 1 2 xy false. Now how this pessimistic locking works, what it does, let's say there is a thread 1, there is a thread 2. Now when thread 1 wants to read and update, I mean fetching the movie ticket or seat details and booking it, at the same time thread 2 is also doing it. Now whoever thread get the first chance, he will log the complete row. The complete row will be logged by thread. Currently let's say thread 1 is get first chance to book the ticket. So what thread 1 will do? Thread 1 will log that complete row, or you can consider thread 1 will log the complete table. Until unless thread 1 not release the log, this thread 2 cannot book the ticket again. In this way, you can avoid completely overbooking issue. Now here thread 1 try to book the ticket, so it will lock the table and thread 2 book the ticket. The status will be changed to true. Okay. Now thread 1 release the lock. Now thread 2 get the chance. Now he went and tried to book it. Meanwhile, he can find the status, okay, it's already booked. It won't allow you to book it again. So the main difference between optimistic and pessimistic, optimistic will not lock the table, rather it will maintain a flag called version, okay, or it will maintain a version number. If there is a version mismatch, then it won't allow to do any modification in the DB. Okay. However, this pessimistic will apply the lock on DB itself, so that if there is ongoing transaction, then all other thread needs to wait till the other transaction is completed. Okay, that is what the main difference between optimistic and pessimistic locking. So let's do one thing. Whatever the theory we have discussed, or whatever the mechanism we have discussed about optimistic and pessimistic, let's see them in action. Let's consider the same movie ticket booking scenario, and let's create a project to demonstrate both the locking mechanism. Okay, and we'll also check the console log or output, and we will also create multiple thread to simulate the exact flow. So let's go to our IntelliJ idea. So to save our time, already I created the template. I have not write any logic here. So let me walk you through the code. If you'll go and check the pom.xml, we are using 3.4.0. However, there is a latest version 3.4.2. You can give a try with that. Since I found some conflict with Lombok, I am using 3.4.0, which is the stable one. And I am using JDK21. I have added the dependency data JPA. This is Open API for Swagger, and I have added web dependency, then MySQL connector and Lombok. That's it. Now if you observe here, I have created a entity class with name seat, and then I have defined all the field what we just discussed, the same schema we have just discussed as part of our presentation, right? So I have created the same id, the name of the movie, and boolean status about the whether the ticket is booked or not, or seat is booked or not. Then I have also created a repository, seat repo. Then I don't have any logic. Then if you'll check, I have just defined the dummy endpoint to trigger the optimistic and pessimistic locking use case, but there is no logic here. Okay, all good. So first let's discuss about the optimistic locking by creating a another column called version. So we have the schema id name book. Then let's create another column, or let's add another column to the existing schema called version. Then we'll validate how optimistic locking work. So just go here and let me define a field called private int version. Then you need to annotate here @version. Now let me create a service class. You can name it movie ticket booking service or anything you can provide. Create this, annotate here @service. Now here you need to inject your repo to book the ticket. Okay, so or to book the seat. Now just define a method to book the seat. Now to book the seat, first you need fetch the existing seat by id. Fine. Once you get that, then you can update the value. So what I will do, I will just use seat repo dot find by id, give the seat id. If don't find, okay, because this will return you the optional. If don't find, then I just want to throw some exception. Okay, now what this will return to you? This will return you the existing seat object from your dv. So I'll just define seat. Fine. Now what you can do, you need to check if seat is booked, then throw some exception saying that it is already booked. Now if it is available, then just do one thing, just update the flag seat dot set booked to make it true, and then save in the dv. So I'll just use seat repo dot save the book entity. Okay, so this is the simple logic I need to define to book the seat. Now I'll just return this. Now what we are doing here, we are just booking the seat. Now when you will do the save or when you will modify something in the dv, then version check will occurs. Okay, now what I will do, I'll just add few log statement, because this book seat method I'll try to access by multiple thread. Let's consider two thread. Okay, manually I will create two thread and I will ask each of the thread to call this method. Then we'll see if two thread will try to access the same method to book the single seat, then how the locking mechanism will work. That is what we want to validate. So I'll just add a log statement here. You can add SL4J, but I will go with the sysout. I just want to print which thread is trying to access this now. Okay, and what he is doing. What I am doing here, I am just trying to print what is the thread and what is the version he is getting. Because what we understand, if thread 1 will book the ticket, or if thread 1 will update the dv, the version value will be changed. But when thread 2 will try to book the ticket again or book the seat again or try to update the record again, the version number should match. If this is 1, then when thread 2 will try to update, if the thread 2 have the copy of version 1, then it will allow. If not, it won't allow. Okay, so that is the reason I just added log statement so that we can see the proper console output. Fine. Now let me create another test class to simulate two thread to call this particular method. So I'll create here only. I'll define optimistic annotate @service. Then I'll just inject the movie ticket booking service here. Next, just define the method public void test. I'll say optimistic locking or something like that. Fine. Now let me create two thread here. So thread 1 equal to new thread. I will use the runnable. Then here what I'll do, I'll just use movie ticket booking service dot book the seat, pass the seat ID. What it will return to you? It will return you the seat object. Okay. Now I will create another thread, thread 2. This guy will also do the same thing. So book the seat. Let's say this guy is, you can give some name. Okay, that's fine. I'll keep thread 1 and thread 2 so that both the thread will try to access the book the seat of same seat at the same time. Okay, then we'll see how this optimistic locking works, how the version number is getting changed, or whether both of thread is able to book the ticket, or how it behave. We don't know the answer. We'll just observe by the result. Now I will also add couple of statement here for better visibility. Thread dot current thread, just copy this. Once it is done, you can add a message successfully. Just append the version seat.get version. Okay, all good. Now let me add the same statement for thread 2. Also, we don't know which thread will get chance, right? It could be thread 1 or thread 2. If thread 2 get a chance, then thread 1 will throw the exception. So to capture that exception, what I'll do, I'll keep them in a try catch. Capture the log. So we can just change it to this thread is failed. Why? Capture the message. I'll do the same thing for thread 2 as well. So here, to just give you the clear picture about the locking behavior, I'm manually creating two threads and trying to execute them. But if you want to test it in better way, you can what you can do, you can do some load testing. Okay, you can concurrently add 10 or 15 or 20 thread and you can test it. You can use JMeter or anything you have for load testing. You can do that, but this way you can get the clear or concrete picture about how the optimistic locking behaves, because you have added the enough number of log statement to get into the flow. That's fine. Now since you have created these two thread, you need to call them. So what I'll do, I'll just use thread 1 dot start. Then forcefully I want to keep few second pause so that the other thread can start at the same time, right? So I'll just use thread dot sleep, let's say for 2 seconds. Just throw the exception. Then just do thread 2 dot start. Also you can give the priority saying that okay, I want thread 1 to execute first, so you can define thread 1 join, after that thread 2 dot join. Hope this is clear for you. Now let's test this out. Just go to the controller class, then just inject the test class you have created. Call it from here optimistic booking test service dot test, this one. Okay, just pass the id, which is nothing, your seat id. Now let me validate whether we have the table exist or not. No, I have deleted it. Let's do one thing, let's run the application so that it will create the table and manually we'll add few record. So start the application. So it started, and does it created the table? Let's validate that. Yes. Now let me insert these records. We have total 5 record, and you need to observe the field called version. Okay, because we are playing with the optimistic locking, and this version play a crucial role in the optimistic locking mechanism. Currently there is no update on any record, so the version is 0. Now what I want to do, let's test this one, Titanic. The id is 2. Now I will go to the Swagger. Let's test the optimistic and give the seat id as a 2. Now let me give you the high level overview, then you will compare the same in our output console or console output to validate what we understand is correct or not, whether optimistic locking is working as expected or not. Okay, so just observe here, we are trying for this one. Okay, the in dv the flag will be 0 and 1. 0 means false. So now let's say there is a thread 1 and there is a thread 2. Now thread 1 and thread 2 will call what method? They will call the method, if you see here, they will call the book seat method. Now in book seat method, what we are doing? First we are fetching the seat from the dv. Now what they will get the information? They will get the information seat id is 2 and booked status is false. Name of the what is that movie? Titanic. Then version is 0. Same time this thread 2 will also fetch, right? He will have the same information, both will have the same copy of existing seat object. Now what thread 1 will do? I mean, we don't know whether thread 1 will get the chance or thread 2 will get a chance. Let's consider thread 1 will get a chance to book the seat by giving the id 2. Once thread 1 execute or book the seat, the value will be changed like this. The booked status will be true and version value will be changed to 1. Now this guy is done. Thread 1 is completed. He is saying okay, I booked the ticket, I will enjoy the movie, no worries. Now this worst fellow thread 2 get the late chance, and once he will execute to update, what it will do? It will do the version check. For movie id or seat id 2, what is the current version we have in dv1? What copy of this particular version this guy have? Thread 2 0. So there is a number mismatch, there is a version mismatch. So this guy will get the exception saying that another thread already modified the record. Okay, because you are having the stale data, you are having the old data which is not up to date. If it is 1, then I could think about something, I will allow you to update. Since you are having the old data, in dv the number is getting already changed because the ticket was booked by someone else, I will not allow you, you just go home. Okay, this is what our expected result in optimistic locking. Let's hit the endpoint and will validate. Clear the console. Wait, meanwhile we have done a mistake here. So this must need to be within the boundary of transaction, right? So we have missed the transactional annotation. Just add it. That's it. Just restart the app. All good. Now let's validate this. Just go to the Swagger and we'll try for this guy. Titanic, okay? All clear here. Just click on execute. This is the result from our controller. Just ignore it. Now go and check your console output. See here. Thread 1. Execute this. But why the number is 1? Okay. It seems the execution is sequential where you don't want that. Now what we can do? I got it. Just go here. We have thread 1 and thread 2. I want both to execute at the same time. Don't add a pause, just ignore it. Now restart the application. Meanwhile, let's check the DV. Okay, this record is already corrupted for us. Let's try for different movie. Let's go with these 3. Okay, we'll try for 3. Now, all good here. Clear this. Just change it to 3. I mean, we are just trying to trying to book this particular seat. Okay, Avengers. Just trigger the request. Now if you observe the output, see here. Now this is correct. Both thread 1 and thread 2 is trying to book the seat. And thread 1 fetch the seat with version 0. Thread 2 also fetch the seat with version 0. Luckily, thread 1 get chance and he booked the seat. Once he update the records, the version is changed to 1. But what these guys have, thread 2 is still having the old version, that is the 0. That is the reason thread 2 failed. What is the error? Row was updated or deleted by another transaction. Can you see here? This is how Optimistic will always validate the version before allow you to modify anything in the record. If the version is not matched, he will simply give you the error saying that what you have and what I have is completely different. You please go and check again. I will not allow you to do anything. Okay. Now your seat booking things will be resolved here using Optimistic. Isn't it? Just go with this output and try to understand the flow we have discussed here. Is it same or not? You need to understand. Okay. So all the optimistic locking will be handled by this version field only. That is what we have in our DV. Now if we'll check here, this one, right, we have tried, the version is changed to 1 and the status is true. Okay, so this is how optimistic locking works based on this version field, and if there is version field is not matched, then you will simply get the error. Hope this optimistic locking is clear for you. If yes, let's move into the pessimistic locking mechanism. Okay, so what I'll do, I'll create another method. I'll copy this. So I'll rename this book sheet with pessimistic. Now what do you understand? What this pessimistic locking will do? He will apply the lock on the table so that if one thread is doing something, other thread must needs to wait until unless thread 1 complete his task. Okay, so what we can do now, this pessimistic lock, you need to do some small changes. Okay, rather than directly fetch by id, just fetch by id and lock that record. The record which you fetch by id and lock it. Just create this method and you can define the annotation here, because find by id is the field. That way JPA will work, but you are trying to apply the lock by your own for that particular entry which you read by id. So for that you need to define the query saying that I just want to select from table name where s dot id equal to what, the seat id. And what another magic you need to do, you need to tell to the JPA or Hibernate, hey, this particular method, when I will find by ID, I want to lock the write access. If thread 1 is writing something, thread 2, 3, 4, how many are there in a queue? They must need to wait. So you need to define another annotation lock, okay, and which type of lock you want, lock mode type, you can see here pessimistic right, you can define that. Now there are different type of lock mode in pessimistic, whether you want to apply the lock only on read or only on write, or optimistic read and write, or force increment. There are different type of lock mode, okay. Do let me know in a comment section if you want to explore all. Otherwise for update and in any modification we can happily go with pessimistic right. Fine, now just close it, this is good. Now go here, there is no because we are returning the seat object directly, right, just clear it. Now here, to understand the pessimistic locking, better we'll change the lock statement little bit. So I'll just copy this, I'll just add here thread, then you can change here. There is no concept of version in pessimistic, you can remove that column from DB, that is absolutely fine. So you can add something, is attempting to, what is that, to book the ticket, or anything you can define, is attempting to fetch the seat with pessimistic locking, or any lock statement you can define. Now here once you get the seat object, what you want to do, better let me do here, fetch the seat with, then here I will just change the statement. Once you get the seat you have the complete lock on that, because you read and apply the lock, okay. So you can define acquire the lock for what seat id, just define it. Now you can modify here, so you can also add here, right, seat already booked, let it be. You can add something here, just copy this. Now again copy this, once the book is successful we don't need any return, okay, keep it void. Now once the booking is success, you can add another lock statement saying that successfully book the seat with id this and who is the thread. Fine, now also I'll add lock statement here saying that this is the thread is already, so no major changes, we just added the couple of more log statement for better visibility. So because we are playing with the multiple thread and one thread will completely acquire the log, because that is what we are doing here, find by id and log the record. So that is the reason we just added couple of more log statement to validate it. Now let's create another test class to just uh, test this particular method. So what I'll do, I'll just create another class like this, annotate @service, then inject the movie ticket booking service, inject using auto add, all good. Now here just define a method to test pessimistic locking mechanism. Next, here also let's create two different thread and call the same method. Created thread 1, created thread 2. Each thread is calling the same method at same time, and then if there is any error, I just captured them and start it, and also join to give the priority to thread. All good. And you understand what we have defined here. Book seat with pessimistic method. We just added the lock statement and we read the entry and lock it so that no other thread can modify it. So that is the reason I have added a proper lock statement saying that acquire the lock by this thread on this particular object. Then if it is not booked, allow to book it and add the lock statement. If it is already booked, give the error. That's it. Okay. All good. Now let's go to the controller and just call this method. Okay, I need to inject that private, the test class you need to inject here, right? Pessimistic booking test service. Now let me call this dot test pessimistic locking, pass the seat ID. Before I start it, first let me validate, do we define transactional? Yes. Without transactional, then there is no use of using this locking, right? Because this locking needs to be within a boundary of transaction. You remember we have discussed about the different type of isolation. In isolation, there is a isolation property called serializable. That also allow one after another, right? Similarly, pessimistic also doing the same, but that on the transaction level. But this pessimistic work by applying the lock on DV level. Okay, all good. Now let me start it. Meanwhile, let me check the DV. We already play with the 2 and 3, ID 2 and 3. Now let's play with the 5. Let's say two thread 1 and 2 trying to book this movie. Okay, but there is a single ticket or single seat, the Dark Knight. Go here, clear everything, go to the Swagger. Now go to the pessimistic, change the ID to 5. Now click on execute. All good. Go and check the console output. Read it carefully. Thread 1 and 2 both try to fetch the seat, okay, from the DV. Luckily, thread 2 get a chance to get the seat and acquire the lock on ID 5. Since thread 2 get a chance, he will do his all the job, then he will release the lock. Now what thread 2 is doing now? Booking the seat. Then he successfully booked the seat with ID 5. After that, see here, thread 2, from here he did all his tasks. He tried to fetch it, he get a chance, he acquired the lock, he booked the seat and he updated the seat. Once thread 2 is done with his work, he released the lock. Now who get the lock? Who get a chance to execute? This guy, thread 1. Now thread 1 acquired the lock for seat ID 5. But that time what he observed? Seat is already booked by thread 2. That is the reason he is getting error. Failed seat ID 5 is already booked. What you understand? Both started at the same time, thread 1 and thread 2. Luckily, thread 2 get a chance to acquire the lock, book the seat. Once he is done with that, he release the lock. Then thread 1 get a chance to acquire the lock. Meanwhile, the record was updated in the DV with the flag booked as a true. So this thread 1 didn't get a chance to go for that movie. Rather, he get the error, seat already booked. Okay. So this approach looks sequential, but this will completely avoid the overbooking issue. Okay, this is how your pessimistic locking works in real time. And if you'll consider a use case of IRCTC or BookMyShow, they internally use the pessimistic locking with in-memory locking and distributed locking. So there are different type of locking mechanism. We just discuss about these two, optimistic and pessimistic, because we are using the Hibernate and JPA. But if you think little more, there are different type of locking available in industry, like distributed locking, in-memory locking, cache locking. There are different type of locking. Okay, so yeah, that's all about this optimistic and pessimistic locking. I hope you are clear with this picture. We didn't discuss only theory, we go deeper and understand the things with the hands-on example, and also I demonstrate the complete flow with the console output. Okay, so do let me know in a comment section if you have any doubts, or also you can add a comment if you are interested for any other locking mechanism. That's all about this particular video, guys. Thanks for watching this video. Meet you soon with a new concept.